Hello and welcome to Formula One. Today we have an exciting presentation for you all presenting our conceptual data science project focused on the world of Formula One racing. This project, developed for the BIT 5524 class by Matthew Curtis, Tiffany Decker, and Corey Murillo, outlines a framework for predicting the race outcomes using public data. Without further ado, let's get into it. We'll start off with the introduction to the project. The project aims to create a pre-race forecasting framework using publicly available data to predict race outcomes. The motivation stems from the complexity of Formula One, a mainly data driven sport where race results depend on numerous variables such as qualifying positions, weather conditions, track characteristics, and team strategies. The framework is designed to provide interpretable insights for external stakeholders such as broadcasters, sponsors, and fan platforms who currently lack structured analytical tools. By leveraging historical data and applying predictive modeling techniques, the project bridges the gap between intuition based predictions and data driven decision making. The emphasis is on transparency and realism, acknowledging the inherent unpredictability of motorsport while offering actionable probabilities and finishing position ranges. This introduction sets the stage for exploring the business need, proposed solution, data strategy, modeling approach, and deployment plan, culminating in a practical application of CRISP DM principles tailored to Formula One analytics. Now, following the CRISP DM framework, we'll start to understand the business. Formula One is a sport characterized by intricate dynamics where race outcomes are influenced by dozens of interacting variables, including qualifying performance, weather conditions, tire strategies, and track configurations. While F1 teams have access to advanced simulation tools and dedicated analytics departments, external stakeholders such as sponsors, broadcasters, and fan engagement platforms often rely on intuition rather than structured analysis. This creates a significant analytical gap in the ecosystem, and the business need is clear. External stakeholders require a standardized, data driven method to quantify relationships between pre race conditions and race results. Such a tool would enable them to make informed decisions, craft compelling narratives, and enhance audience engagement. The goal of this project is to develop an interpretable forecasting framework that uses historical data to estimate probabilities of podium finishes and predict finishing position ranges, all based on information available before the race begins. This approach ensures realism and accessibility, empowering stakeholders without the technical resources of F1 teams. And here's what we propose to do about it. The proposed solution is a conceptual analytics framework designed to estimate two key outcomes: the probability of a driver achieving a podium finish and the expected range of their finishing position. A critical constraint is that the framework relies exclusively on pre race data, such as qualifying results, weather forecasts, and historical performance trends. This mirrors the real world limitations faced by external stakeholders who do not have access to live telemetry or in race data. The emphasis is on explainability rather than deterministic predictions. Instead of claiming exact finishing positions, the framework articulates how variables such as starting grid position, track type, and team momentum influence the distribution of likely outcomes. By presenting probabilities and ranges, the model maintains transparency and acknowledges the inherent variability of motorsport. This approach provides stakeholders with actionable insights while preserving the excitement and unpredictability that define Formula One racing.
Next, we will discuss the data strategy, starting with data understanding. Building the forecasting framework requires comprehensive data that links drivers, teams, tracks, weather conditions, and historical race results. The primary data source identified is Fast F1, an actively maintained library offering detailed historical data and seamless integration of weather information, which is crucial for modeling environmental impacts on race outcomes. As a secondary source, a Kaggle repository covering Formula One data from 1950 to 2024 provides a static, well structured data set suitable for retraining models or filling gaps in the primary source. The selection of these sources ensures both depth and reliability, enabling robust feature engineering and model development. By focusing on pre race data, the framework aligns with the practical constraints of external stakeholders, ensuring that predictions are based on information realistically available before the race begins. Next, we will talk through data preparation. Data preparation involves rigorous cleaning and validation to ensure accuracy and consistency. Categorical variables such as team and driver names are converted into numerical formats, and constraints like a maximum of 2 drivers per team per race are enforced to detect anomalies. Feature engineering enhances predictive power by creating new variables that capture critical aspects of race dynamics. Boolean indicators identify conditions such as rain affected events, while calculated metrics include total pit time per driver and average pit time stops per constructor. Momentum indicates track performance trends over the last 3 races, providing insights into drivers' trajectory. These engineered features enrich the dataset, enabling models to capture nuanced relationships between pre race conditions and race outcomes, ultimately improving interpretability and predictive accuracy. Moving on to our data modeling approach. A modeling strategy employs 2 complementary approaches to translate complex Formula One factors into structured, interpretable predictions. The first model addresses podium probability as a binary classification problem, estimating the likelihood of a driver finishing in the top 3. The second model predicts finishing position as a continuous regression problem. Both models rely exclusively on pre race data to maintain practical relevance. Historical data is partitioned into 70% training and 30% validation sets to ensure generalization and robustness. The dual approach balances simplicity and complexity, providing stakeholders with both high level probability and detailed finishing position estimates. By combining classification and regression techniques, the framework delivers comprehensive insights into race dynamics while preserving interpretability.
Now I'll walk through the evaluation and deployment phases of our project, which explains how we assess our models and how these insights would ultimately be delivered to the stakeholders. Starting with evaluation. For evaluation, we're checking whether our chosen models actually meet stakeholder needs. Logistic regression predicts podium probability, and we expect the factors driving that probability to align with real-world patterns. Our random forest model predicts finishing position and is well suited for the nonlinear and unpredictable nature of F1 data. We want to see if we can generate insights that stakeholders can rely on, not just theoretical predictions. If both models behave consistently and produce usable context appropriate outputs, then they're successful in their intended purpose and ready to move on from the conceptual stage. Now we'll talk about what the models will output. This conceptual model output shows how our 2 models work together to generate meaningful insights. The logistic regression model provides a clean probability estimate for a podium finish, while the random forest predicts an expected finishing range. For example, a driver starting first on a traditional dry track might show a high podium probability and a low predicted finishing position, whereas a driver starting eighth in rainy conditions would have a much lower podium probability and a higher predicted finish. This dual output helps stakeholders understand both the likelihood of success and the factors driving these predictions, supporting more informed decision making and narrative development. We plan to present the model and its output through a clean, modern dashboard designed for external stakeholders such as broadcasters, analysts, and fans. It will display the model's pre-race predictions and probabilities, along with key factors that influence those outcomes. We'll also provide insight into how these factors shape the predictions. The goal is to deliver clear, interpretable insights that support commentary and gives audiences a stronger data-driven understanding of expected race performance. Summary of both evaluation and deployment is as follows. In evaluating our system, we go beyond statistical accuracy and focus on whether the insights actually help answer the business problem. We're looking for probability estimates and patterns that make sense in the context of Formula One. For example, whether strong qualifying matters more on certain circuits or under specific conditions. Reliability means producing consistent directional trends rather than perfect predictions. This is because the sport is inherently unpredictable. On the deployment side, dashboards are tailored to broadcasters and fan platforms. These views highlight predictions and the key factors driving them, helping shape the narrative before a race. For continuous improvement, the system must stay current over time. Racing trends evolve, so race data will be refreshed routinely and the model retrained periodically to capture these changes. And now let's tie everything all together. To conclude, our project provides a straightforward way for external Formula One stakeholders to receive race predictions and also to understand what features influence these outcomes. By using public data and models that are easy to interpret, we create predictions that clarify why certain results are more or less likely. Our dual model approach balances realistic race behavior with clear, explainable outputs. Overall, the framework gives stakeholders meaningful insights that are easy to understand and apply. This will help support commentary and improve engagement heading into each race.